This skeletal system is moved by something called tendons. Tendons are highly inelastic, not totally, but highly inelastic. For the most part, they connect muscle to bone. They glide lubricated sheaths called synovial sheaths, and their job is to move the animal. Then we have ligaments. Ligaments hold all this together, so they are for support. For the most part, they connect bone to bone, and they are elastic. So there's more elasticity in a ligament than you're going to find in a tendon. Okay? So we'll start with our tendons. There are 4 tendons that we need to learn: the flexor tendons and the extensor tendons. Now, to the dorsal side, I have my main extensor tendon. Really, the main extensor muscle, the courses distad, insert proximal P1, proximal P2, and the extensor process P3. Lay into the lateral side of that, we have my lateral extensor tendon. Really, the lateral extensor muscle, the courses distad, and inserts into proximal P1. Now, that's pretty light, thin tendon. Here you can see a thoracic leg. There's my main extensor. There's my lateral extensor right beside it. Okay? So that's kind of what we have drawn right there. Now, on the pelvic side, or I'm sorry, on the palmar aspect of the leg, I got my deep flexor. So the deep flexor muscle, of course, is distad around the sesamoids, around the navicular, and inserts in the semilunar crest of the coffin bone. Now, the semilunar crest is a partial moon shape on the distal end of a coffin bone. So semilunar means partial moon. If you look at the bottom of a coffin bone, this is a hind coffin bone. If you look at the bottom of a coffin bone, you can see that partial moon shape. That partial moon shape is the insertion for that deep flexor tendon. Now laying behind that, or palmar to that, is our superficial flexor. The superficial flexor muscle, it forces distad, forms a collar around my deep flexor to proximal sesamoids, and then bifurcates below the fetlock to insert collaterally on distal P1 and collaterally on proximal P2. So the word bifurcate means to divide into 2. In essence, you have your superficial flexor tendon coming down around your deep flexor, and so at this point where it divides, you can see the deep flexor through it. And then it's going to insert on both sides of distal P1, that's what collaterally means. Collaterally distal P1, collaterally proximal P2. What you see on the lateral, you're also going to see on the medial. Okay? So it's one origin, 4 insertions for the superficial flexor on the thoracic. Now, when we move to the pelvic, things change up just a little bit. First, our main extensor, which you'll sometimes hear it called the common extensor in the front leg, the long extensor in the hind leg, but main extensor is kind of the generic term for both. Main extensor, again, main extensor muscle, coursing distad, proximal P1, proximal P2, and the extensor process of P3. Oh, and the extensor process I didn't show you a while ago. The extensor process is this bone prominence on the dorsal proximal border of the coffin bone. So this little hump right here, that's the insertion, the distal insertion for my main extensor tendon. And beside that, we have our lateral extensor, the lateral extensor muscle. Now as it courses distad, it joins the main extensor tendon. So we said earlier, one of the rules of a tendon is it connects muscle to bone. So here we have a tendon that is an exception to that rule. Instead of muscle to bone, it's muscle to tendon. Behind that, we have our deep flexor and superficial flexor. Our deep flexor from the deep flexor muscle, of course, is distad, again around the sesamoids, around the navicular, inserts in the semilunar crest of the coffin bone. And behind that is my superficial flexor. Now this is where it gets quite a bit of change. My superficial flexor muscle, of course, is distad, and its first insertion is what we call the calcanean process on the fibular tarsal bone. The fibular tarsal bone is also sometimes called the calcaneus as well. But the first insertion for the superficial flexor tendon is on that calcaneus. Then, of course, the distad forms a collar around the deep flexor proximal sesamoids, bifurcating below the fetlock, and inserts collaterally on distal P1, collaterally on proximal P2. Okay, so those are your main tendons that you have to know about. And you need to understand how, when you shoe a horse, you affect these. All right? You know, anatomy is a little bit like math. Sometimes you learn it and you wonder, why am I learning it? Why am I bothering with all this? Well, there's some very good application. So here's a very practical application for you. This is thoracic leg, okay? So this does not really hold as true for the pelvic limb. I always draw my C4 too small. Okay, Now, first we need to impose a foot on here. So my foot's going to come right just to the distal end of my P2. It's going to be parallel to my hoof wall and my dorsal coffin bone. And then my coffin bone should have a slightly positive angle in relation to the foot in the normal biomechanical model. Okay, that's what we consider ideal. If we have a negative palmar angle or flat, that's not considered a good thing. Just a quick indication, the position of my navicular bone, a lot of people don't know where that is. It is at the widest part of the foot, about a ½ inch below the coronary band. You know, I think a lot of horseshoers and horse owners themselves think the navicular bone is much lower. It's way up here. And so that's kind of represented there. All right, so there's my foot. I have my deep flexor. I'm not going to worry with my extensor tendons. My deep flexor is going to come down around my sesamoids, around my navicular, the similar crest coffin bone, and behind that, my superficial. Okay, now this is where an understanding of anatomy is going to really help us. Okay, here's the first point we need to make. Whatever I do to the hoof capsule, the coffin bone has to accept. By that I mean, if I were to take more toe and make this hoof capsule steeper, then that coffin bone would have to be steeper. And if I take more heel and make it shallower, that coffin bone would have to be shallower. So my coffin bone is locked into whatever I have to do to my hoof capsule. Okay? If we have natural angle, and by natural, I'm not trying to open up any ugly words. Natural angle is simply stated as a line through the center of the pastern, be parallel to the dorsal wall. If I have natural angle and I have a good perpendicular load on my cannon bone, I am happy, and most of my horses are comfortable and happy in a static model. Okay. Now, if I make this thing artificially steep, whether by artificially I'm talking about putting a wedge pad on, a wedge shoe, or making them steeper than he should be. In order for that foot to find the ground, it will have to rotate in this manner. If it rotates in that manner, I'm going to change the distance from point A to point B, origin to insertion from my deep flexor tendon. I will, in effect, move that point closer to the origin. By doing that, by shortening that distance, I'm going to take some stress on my deep flexor. Well, I allow stress to come off my deep flexor, that will allow my fetlock to descend. If my fetlock descends, I will end up with a steeper hoof, but then a pastern at a lower angle. So whenever I gained angle on the hoof capsule, I lost angle in the pastern. Okay? Now, since this is lowered, my superficial flexor has to go further from point A to point B because this angle has changed, and now I'm putting stress on the superficial flexor. And the next thing to throw into that is whatever happens to my superficial is also going to happen to my suspensory ligament. Okay? So let's take this the other direction. Let's say we made this thing artificially shallow. Trimmed off all the heel, put a reverse wedge pad on. In order for this foot to find the ground, the heel is going to head towards the ground and is going to pull that deep flexor tendon tight. I'm going to move these 2 points further apart, making that deep flexor tendon in the stress position. How I do that is going to push my fetlock forward because of all the pressure on the deep flexor. Now I'm going to have this long toe, low heel type horse with a very upright pastern. Does everybody understand? You guys out there in the internet land? Okay? So there's a good practical application that tells you why you need to understand anatomy. If I have a customer who wants me to do something to an animal that does not make sense for that animal, then I can draw this out and I can explain it and I can make it simplified for the customer to understand why I'm not willing to do this or do that. So natural angle, I want to have a lot more comfortable horse.